Dear viewers, welcome to another video on YouTube tutorials. In this video, we are going to understand how to use graphical summary, which is a very interesting and most used option of Minitab. Let's understand that in this video. As I was explaining, in this video, we are going to understand how to draw graphical summary and how to interpret the results of graphical summary in Minitab. As I was explaining in the introduction, graphical summary is one of the most commonly used graphical and descriptive statistics summary that Minitab provides us. In a single window, we will get to know a lot of information about our data. So let's understand how to perform a graphical summary. So let me explain you the data that I have. So this is average handling time of a team in a contact center. This is time to assemble mobile phones in a mobile assembly process. This data that you have in the C3 column is price of onion for the last 100 weeks, quarter kg price of onion from a local market. This is thickness of a machine to component, and this is also length of a machine to component. So these are different data that we have, and we will use this data as part of our video to explain graphical summary. Let's understand. Let me click on stats. Let me click on basic stats, and here I have an option which says graphical summary. So the mouse pointer has now explains summarize your data. Summarize your data with descriptive statistics such as the mean and the standard deviation, and describe the distribution with graphs. So it gives you a descriptive statistics. Also, it gives you graphs which tells or which helps you to understand some information about what kind of distribution that it follows. So let me click on this, and as I click on this, you will find that there are two columns. One column talks about your variable, another column talks about if you want to have multiple descriptive statistics or graphical summary for same set of data with two variables or more than two variables. Let's understand what it is. I have a sample data for that. Let me explain how it works with the sample data, but as of now we will go with a single variable. And in the confidence level column, it is given as 95%. I'll also explain what is this confidence level. Let's now go with the average handling time in a contact center to answer customer queries, the call duration. So this is the data that I have taken, and I am going to click on OK. When I click on OK, you get a graph like this. Let's maximize this graph and get a better view of this. So if you see here, you have a histogram of the data. Then you also have a box plot of the data. So what is histogram, what is box plot is been already explained in some of my previous videos. So I will share the description of those videos for you to have a better understanding. If you are listening these words like histogram and box plot for the first time, I would request you to kindly go back and listen to those videos. And it also gives you a confidence interval estimation of mean and median. So it gives you the sample statistics, and with sample statistics, what will be the corresponding confidence interval estimation. Again, what do we mean by confidence interval? How to calculate that? There is a separate video on that. I would also share the description or link of that video in this description. You can listen to that video if you still need more clarity on what is confidence interval. But let me try and explain briefly in this video about all these concepts. To start with, a histogram is a graphical representation of the frequency distribution table, or in other words, it tells you the spread of the data. And this red color line that you see on the, or which is overlapped on the blue color bars, which is the histogram, the red color line which overlaps is a standard normal distribution curve. So how well is this data fitting to the standard normal distribution curve? And if you see here, one side the tail is much more visible and the other side the tail is not so visible. So what does it mean? It means this data does not exactly fit into a normal distribution curve. It does not mean it is not normal, but what we can understand is this is not a perfect normal distribution, standard normal distribution. That's not the case. That's what we understand by trying to fit a standard normal curve on the histogram and see how well it fits. It does not fit exactly on the histogram because one side you have an extended tail. If you see here, one side you have an extended tail. And what you can understand that you can understand there is a box plot for the same data. On that side, if you see on the bottom quartile, generally we say this as the top quartile, This is the third quartile, second quartile, and bottom quartile. The bottom quartile is quite extended, and there is also a star here, which means there is a outlier, right? So then you have your mean and median and their confidence interval. I'll give you a brief explanation of how to interpret this in this video, but there is a detailed explanation which I will share. The link will be shared in the description. So what is confidence interval for mean and median? If you see here, the number of data points used to perform this graphical summary is 100 data points. So what we need to understand is there is a larger population, but we have taken a sample of 100 from that larger population, and from that sample of 100, the test or the sample statistics, in this case, if you calculate average for a sample, we call it X bar, which is sample statistics. So the X bar of this 100 data points is falling here. So where will be the mu falling? Mu is, in other words, the average of the population. I only know the average from this 100 data points, but where do you think the average of the 500 data points will fall? That will fall anywhere from this point to this point. And I'm saying this with 95% confidence. That's what we mean by 95% confidence interval for population parameter from sample statistics. So why do we have such a wide interval? Can this interval be narrow, or it will always be wider? This have various parameters into consideration. Some of the parameters are what is the variation in the underlying population, how much is the standard deviation, and also how many samples that you pick up. So these are things, how well you pick up your sample, how random your sample is, how representative your sample is. All these have a role to play in how much will be your confidence interval. So at this point of time, you can understand it is an estimation of the population parameter from the sample statistics. That is on the graphical side. Let's now come to the statistical summary here. So as you see, there are multiple sections to this, but first we will understand from the topmost. So the topmost value, the A squared value, which is the Anderson-Darling test statistics value. At this point of time, it will be difficult for you to understand if you are not familiar with Anderson-Darling test. Maybe in a different video, I will clearly explain how is this A squared value is getting calculated. Maybe at this point of time, what you can focus is, you can focus on the P value. P value is the probability value. And generally, when you do a normality test, if your probability value is greater than 0.05, you can understand that you can assume this data is normally distributed. If it is all the way up to 1, which means it is a standard normal distribution, which is theoretical, you may not get in a real-time scenario, but as the value get closer and closer to 1, you can understand this. The chances of this data being perfect normal distributed or standard normal distribution is high. And what is the other side? The other side is, if this p value is less than 0.05, then you can decide this data is not normally distributed. Many times during our descriptive statistics analytics or our predictive statistics analytics, for certain statistical tools to be used, for example, your hypothesis test, one sample t-test or two sample t-test, or analysis of variance, for many of these tests, one of the prerequisite condition is your data should be normally distributed, because the formulas, the statistical calculations of those tests are calculated or designed based on the assumption that the underlying data is normally distributed. So the first section in the descriptive statistics talks about whether your data is following normal distribution or not. Then comes your mean, standard deviation, variance. So these are things that you already know. Mean, standard deviation, and variance are descriptive statistics on central tendency and the variation in your data. Then you have skewness and kurtosis. These are maybe two new words that you will be listening. So I'm planning to explain skewness and kurtosis in detail in my following videos, which I will upload very soon. But as of now, what you can understand is skewness talks about the symmetric nature of your curve. So what do we mean by that? Whether we have equal amount of data on both sides, or this particular curve, the histogram that we saw, is it symmetric? And as you see here, it's not symmetric because there is more data on one side of the curve, there is less data on the other side of the curve. How do I understand skewness? Skewness 0 means the perfect normal distribution curve. That means it have equal variation on both sides. Skewness with a higher negative value or skewness with a higher positive value means this data is not symmetrically distributed. It is having more data on one side and less data on the other side. So there are multiple types of skewness: right skewed, less skewed. All these I would be explaining in my detailed video, which I will upload soon. The next terminology that we need to understand is kurtosis. What do we mean by kurtosis? Again, kurtosis talks about the nature of your tile. When I say nature of your tile, if you see, this is what we mean by tail. So the mouse pointer that I'm moving here, this is what we mean by tail. So if you see, the value of kurtosis indirectly tells you whether your tile is light or your tile is heavy. So what do you mean by tile being light or tile being heavy? So if you see here, if you have outlier, that means there are more data points towards the tail. So that is called a heavy tile. If you do not have outliers and your data or the underlying data do not have outliers, then we will say your tile is light because you will not have more data point towards your tail. If you see here, the data completes here and the tail is light on this side, whereas the tail is heavy on this side. So that's why you see a tail or the kurtosis value which is on negative side. Again, kurtosis negative, positive indicates which side of your tile is heavy, and also it indicates, the number indicates how heavy is your tile. So the perfect standard normal distribution should have kurtosis 0. So skewness 0 and kurtosis 0 is an indication that your data is following standard normal distribution. As I told, it's not that easy or it's not that frequently that you will get a data where your skewness and kurtosis will be 0, but still I'll have some examples to show to you, which I will show as we move on in this video. Then you have your minimum value, which we all know, the lowest value in our data set. Then we have our maximum value, and as part of box plot I would have explained about quartiles. So as I was explaining, so you have your first quartile, third quartile, median. So all this information you see here, and what you see here as a graphical representation, the confidence interval for mean and median, the same thing is given here as a statistical values, and you also get a confidence interval for your standard deviation. So this is what you see in a graphical summary. It gives you a complete picture of your data, both graphically as well as statistically. So it helps us to summarize the central tendency, helps us to summarize the variation, it helps us to give a understanding about what kind of distribution our data follows, both statistically as well as graphically. That's the big advantage of using graphical summary. Now I'll show you few more cases. So let me press Ctrl E, and now I'll change to assembly AHT. So this is the time to assemble mobile phones. And now if you see here, the values would have got different. For example, the skewness and kurtosis values, if you see here, now the p-value is more and more closer to 1. Still it is not a perfect normal distribution or a standard normal distribution. The mean and median are more or less close to each other, but again you see your tail are not same and the data distribution is not uniform on both sides, because if you see the box plot on all the 4 quartiles do not have the same kind of variation. The variation is less here, the variation is more this side, the variation is more this side, the variation is less. So these are things that helps you to understand about whether my data is skewed or not. So just to understand this better, let me show you a extremely skewed data, price of onion, and we all know price of onion cannot be controlled, and there are certain data points where it will be beyond all our control. So now if I click OK, if you see this graph, you will clearly understand now the skewness and kurtosis values. It's nowhere close to 0. In fact, it is very high on the positive side. It's very high on positive side because if you see here, this is where your tile is getting heavier and heavier, and that's why if you see your kurtosis value, it is 7.9. In our previous examples, we saw it somewhere around minus 0.01, like that. It was very close to 0, even though on the negative side. But this time, if you see, it's a very high value on the positive side. Same is the case with skewness. So skewness also is a very high value. Both indicates that this data is not symmetric as well as the tile is heavy. Now we'll come to a very easy to understand example, thickness. So if you see here thickness, and if I say okay, you will find that again the p-value is not closer to 0, closer to 1. So it's not a standard normal distribution. Whereas if you see skewness and kurtosis, yes, there is some skewness, there is some amount of kurtosis. That's why the values are not close to 0, and you can see an outlier here. You can see a outlier this side. Now the last set of data that I have is a almost a perfect normal distribution, a standard normal distribution, length of a machine to component. And in this example, if you see, you will be able to find that the value of kurtosis as well as the value of skewness is almost close to 0. And if it's getting almost close to 0, and you will find almost an alignment towards the highest bar and the box plot. there is an outlier, and that's why the value is slightly getting on the not perfectly close to 0. There is an outlier, but more or less the alignment of your mean median is almost close. The intervals are close, as well as your box plot, median line, and the mode bar, or what we call it as the peak of your curve, almost more or less it is close to each other. So this is the understanding of the statistical values and graphs that you see in a graphical summary. Just to make it even more interesting, I have one example data. Let me open the data. So here I have carbon dioxide emission, CO2 emission from 3 different diesel generators that we have. So let me paste the data here. So now what I'm going to do is I'm going to generate graphical summary for CO2 emission, but that CO2 emission data is arranged in a way where the variability or the factor is in one column and the response is in another column. So I'm going to again click on stats. I'm going to click on basic stats. I'm going to click on graphical summary. This time CO2 emission will be my response variable, and my categorical or optional variable is my genset. And now if I click OK, I'll be able to get this particular data for my genset A, for my genset B, and for my genset C. So I'll be able to generate all the 3 graphical summaries in one go. This is not the only way in which we need to do. For example, assembly AHT A and assembly AHT B. So just a minute. So I have an example where there are 2 teams, team leader Mike and team leader David, and their call duration data is also available with me. But here the data is not arranged in the same, that means you have response parameter in one column and the factor parameter in another column. No, each response parameters are in a single column. Then also we can click on stats, we can go to basic stats, and we can go to graphical summary. This time I can select team Mike, I can select team David together in the variable parameter, and I can remove this categorical optional variable. I can remove it. I can click OK. Then also I'll be able to generate team Mike graphical summary and team David's graphical summary. Friends, I hope this video was useful for you to understand how to draw graphical summary in Minitab. And once you get your graphical summary, what does each of this section talk about? What does the histogram talk about? What does the box plot talk about? What is this confidence intervals of mean and median talk about? How should I understand the p-value? How should I understand kurtosis? How should I understand skewness? And how should I understand all the other statistical parameters that you see, descriptive statistics that you see with respect to this particular data. I hope this video was useful. For if you want to get more understanding of different options available in Minitab, graphical representation, different statistical tests that we can do in Minitab, please subscribe to our channel. Thank you.